Welcome to Asin Code. Hit like, subscribe, and let's continue this amazing journey of coding and learning together. Overfitting in neural networks occurs when a model learns not only the underlying patterns in the training data but also the noise or random fluctuations, making it overly complex and specific to the training data. This leads to poor generalization on new, unseen data. During training, the model minimizes the loss function, like mean squared error, on the training set, but if it starts to memorize the data, the validation loss, measured on unseen data, will increase while the training loss continues to decrease. This is a sign of overfitting. To prevent it, techniques like early stopping, regularization, and using simpler models or more data are commonly applied. In practice, we can monitor the training and validation loss curves over epochs. A gap between them indicates overfitting, and adjustments can be made to improve the model's ability to generalize to new data. Sequential class to define a linear stack of layers. Dense class is used to create fully connected layers. Function to split data into training and testing sets. Generate synthetic data. NumPy.lenspace generates an array of evenly spaced values. In this case, 500 points between -10 and 10. X is the independent variable ranging from -10 to 10. Y is generated based on a quadratic function y equals x squared, with some random noise added using np.random.normal. This mimics real-world data where there's always some level of noise or randomness. Y is the dependent variable, quadratic data with noise. Split the data into training and testing sets, 80% training, 20% testing. Train_test_split is a built-in function from Sklearn that splits data arrays into random train and test subsets. The random_state is set for reproducibility so that the same split happens every time we run the code. Reshape the data to be compatible with Keras input expectations. Keras expects the data to be 2D for input, with shape, samples, features. In this case, we have one feature per sample. Reshape x_train to 2D, 501. Reshape x_test to 2D, 101. Build the neural network model using Keras Sequential API. The sequential class in Keras is used to build models layer by layer in a linear fashion. Add the first dense layer. Dense layers are fully connected layers where every input is connected to every output. This layer has 10 neurons and uses the ReLU, rectified linear unit, activation function. ReLU is commonly used for hidden layers because it helps with learning and avoids issues like the vanishing gradient problem. Input_dem equals 1 specifies that the input has one feature per sample. Add the output layer. Since this is a regression problem, we only need a single output neuron. For regression tasks, the output layer typically does not have an activation function, so it's left as a linear output. Output layer with a single neuron and no activation function. Compile the model. In this step, we specify how the model should learn, i.e., the optimizer and the loss function. ADAM is an optimizer that adjusts the learning rate during training. It's popular because it's computationally efficient. MSE, mean squared error, is used as the loss function for regression tasks. It measures the average squared difference between predicted and true values. Train the model. In the fit function, we provide the training data, x_train and y_train, and the number of epochs, 200. The batch_size equals 32 means the model will update its weights after processing 32 samples. Validation_data specifies the validation dataset to monitor the performance of the model during training. Plot the training and validation loss over epochs. We will visualize how well the model is performing during training to spot potential overfitting. Overfitting occurs when the model performs well on the training data but poorly on unseen data, test set. We plot the loss for both training and validation datasets to detect overfitting. Validation loss curve. X-axis represents the number of training epochs. Y-axis represents the loss value. Adds a legend to the plot to differentiate between training and validation loss. Explanation of overfitting. If the training loss decreases while the validation loss starts increasing, this is a sign of overfitting. Overfitting happens when the model learns to memorize the training data rather than generalize to new, unseen data. This is problematic because while the model will perform well on the training data, it will fail to generalize to new data. Now run our code. Hope you enjoyed the video. Like and subscribe for more fun content.